Hey everyone, welcome back to my YouTube channel, and if you are watching this video for the first time, please find the link in the description of the entire playlist and hit the subscribe button, because every time I come up with some new questions and I make sure to provide some new concept to my viewers. So please don't miss the chance and hit the subscribe button. In this video we will be looking into one of the popular question, majority element in an array, and we will look into various methods to solve it and write the code in Java at the end of the video. So please be with me till the end of the video. So now let us look into the problem. A majority element in an array of size n is an element that appears more than n by 2 times. That means if we are given an array, we have to find an element which has occurrence more than the size, half of the size of the array. For example, in this array, first array given to us, if we look into the elements that 1, 2, 4 and 7, these are the different elements present in the array, and there are total 8 elements in the array. So half is 4. So if we can find some element which has more than 4 number of occurrence, then that is our majority element. So if you look here, so 1 is present 1, 2, 3, 4 and 5 times, which is greater than 4. So the output is 1. In the second example, 2, 4, 7, 9, 3 are the distinct element. So if you calculate, 2 is present 2 times, 4 is present 2 times, 7 is present 2 times, 9 and 3 are only one occurrence. So none of them are greater than 4, so therefore we have no element found. Alright, and please note there can be at most one such element, because no two element can have occurrences which is greater than n by 2, right? So only one element will be there or none of them. Okay, so please try to write the code by yourself first, and we will start the solution now. Now let us look into the solution of the problem. So I will be discussing two methods. First I will be discussing a naive approach, that is a straightforward approach of solving a problem. And later on, I will be discussing a more popular way of solving the problem using Boyer-Moore majority voting algorithm. Okay, so the naive approach is very simple. We will be having two loops, a nested loop. The outer loop will be starting from 0th location till the end, and the inner loop will be starting from I plus 1th location, and it will be calculating how many times the ith location element has occurred in the array. Okay, and if it is greater than n by 2, then it will directly return that element. Otherwise, it will keep on going till the end. I will keep on go till the end, and if it has not found such element, then it will return -1. So let us look into the workflow. So suppose I starting from this index, and j will be calculating how many times 2 is there in the array. So initially count equals to 1, and j will be starting with second location. So 4 is not equals to 2, it will be incremented. 3 is not equals to 2, it will be again incremented. 2 is equals to 2, so count variable, now it will become 2. Now this variable will increment, and 2 is again equals to 2, so count value will become 3 now. The j value will be incremented. 6 is not equals to 2, so count value is going to be same as it is. Now it will again increment, and 2 is equals to 2, so count value will again increment, and it will become 4. So how many elements were there? 7. 7 by 2 is 3.5, so we'll consider the floor, that is 3. So if we are having an element which has more than 3, that is 4 or more than 4 occurrences, then that is our majority element. So here we found that 2 is having the number of occurrences as 4, so we'll return the value of index 0. If other case, if 2 would not have been the majority element, then suppose here we have 3, so the number of 3 we will calculate, and if it is not greater than n by 2, then I will now increment it will point to the first location. Now j will be starting with this location 2, right, and it will go till end, and it will try to find out how many times 4 is there in the array. Similarly, I will again increment, it will comes to 3, and j will start with the third location, and it will count how many times 3 is there in the array. J will be not starting from index 0, because the previous indices we have already covered, so that's why j will be starting with I plus 1th location. So now let us look into the time complexity of method 1. So we are having two loops, right? So I is starting with 0, and it is going till n, and j is starting from I plus 1, and it is going till n in each iteration, right? So I will be not going in details, but we will be having an overview of how it is calculated. So approximately j is running for n minus I times, and how many times this is happening? I is traversing from 0 to n, so I is running for n times. So if you multiply n with n minus 1, n minus I, we will get n square minus ni, or when we calculate the worst case time complexity, it is going to be n square. Okay, So So now let us look into the second way of solving the problem, and this method is also known as Boyer-Murray majority voting algorithm, and it will solve the problem in order of n complexity. So now let us see how it is going to do it. So it is a two-step approach. In the first step, we are going to find the majority element index. Okay. In the second step, we are going to verify whether the returned element index or the returned element is actually majority element or not. So why we are doing this verification? If the majority element is present in the array, that is going to return the index of that majority element, that for sure. But if it is not, then we are not sure whether the return index is the majority element or not. So for that case, we need to verify it. Now it will become more clear when we will start the workflow. So initially we will be having two variables, count and m index. M index is nothing but the majority index. Okay. M index variable. So initially m index is 0 and count is 1. So this index is pointing to the first element, and we assumed this is the majority element as of now. So the moment we will encounter a different value, we will decrement the value of count, and if we encounter the same value, we will increment the value of count. If count has become 0, then we will shift the majority index to that different element which made count variable as 0. Otherwise, we will continue till the end of the loop and we will return the majority index at the end. Let us see how it is happening. So initially m index is 0 and count variable is 1. So now it will come to the second location and this is not same. So it will decrement the value of count. And now we see count is 0. So m index will become now what? The first index. Now we'll again check. With what? We'll increment the pointer to the third location, and we saw that the m index value, that is 4, is not equals to 3. Sorry, in the previous case we had to increment the value of count also. Now 3 and 4 is not equal, so we'll decrement again the value of count. Now it has again become 0, so we have to shift the m index value to the location 2. Now, and count variable will be incremented. Now this pointer will be incremented. Now 2 and 3 are not equal, so we'll again decrement the value of count to 0, and once we see okay this is 0, so m index value has to shift now and it will point to the third location. Now we will be again incrementing the pointer. Here we have to increment the value of count also. Now we see 2 is equals to 2. Now the count variable will be incremented and it will become 2. Now again it will be incremented. 6 is not equals to 2. It will be decremented, but now m index is going to point in the same location only because it is not 0, it is 1 only. So now again it will be incremented. So 2 we got same, 2 equals to 2. With m index we will compare. 2 is equals to the value 2, so it will again incremented. Now we'll come out from the loop, and m index, that is 3 index. Index 3 contains 2. This will be returned. When we get the value of the index, now we have to do the second step, verification, right? So in the verification, it is very simple. We have to iterate through the array and we have to count how many times the third index value, that is 2, occurred in the array. So that is very simple. We just need to compare each element with 2 and we have to increment the value of count. So if count is greater than n by 2, then we can say it is the majority element. If not, then it is not a majority element. I know you all are having so many doubts. Wait a minute, I will take different cases and I will explain you, because even I got the same doubts when I understood this concept for the first time. Don't worry, I'm going to take different cases. Suppose we are having 1, 2, 3, 4 and 5. These all are distinct, no majority element. So what count will have? Count will point to the first element. M index is going to point to the first element now. Count is 1, it is different, so count will become 0. M index now point to the location 1, 0, 1, 2, 3, 4, location 1. So now for the count will also increment now. Now it will shift here. Now we'll compare, again it is different, it will again become 0. Count it, m index is going to be 2 now, and it will be incremented. The pointer will increment. 4 is different from 3, so what will happen? Count value will become 0. As it is 0, so we will shift the m index value to the location 3. Now this pointer will be incremented. We will be having increment count by 1, and 5 is not equals to 4, we'll increment it. 5 is not equal to 4, again it will be 0, and this m index is going to point the location 4. Now for the location 4, it is going to come out from the loop. Count is now 1 also. It is going to come out from the loop, and we will be returning the index 4. But is our index 4th element, that is 5, majority element? No. So that's why we need to do the verification process. In the verification, we will be step 2. In the verification process, we will be finding how many times 5 is there in the array. So 5 is only once. And how many elements are there? 5 elements. So 5 by 2 is 2.5. So we have to check whether the element is greater than or equals to 3 or not. So 1 is not greater than or equals to 3. So there is no majority element. Alright. So if we have all the elements as same. So 1, suppose 2, wait a minute. 2, 2, 2, 2, 2. All are 2. So what will happen? Count will be having initially value as 1, and m index will be pointing to this 2. It will be incremented again and again. Count value will be incremented again and again, and at the end it is going to return this value only, and it is the majority element. Suppose I will take a different example now. Suppose we have 2, 2, 1, 1, 2, 2. How many elements are there? 6 elements. How many times 2 is there? 4 times. So 2 is the majority element. Now we will check whether our algorithm is working perfectly or not. So initially count will be having 1. When it will come here, count will become 2. Now 2, 1 are there, so it will make it 0. Now m index will be pointing to this one. Now we will start comparing this one with 2. It is no, it is not equal. So count variable, it was 1, then again it will become 0. Now it will point to this 2. M index is going to point this 2, and count is 1. When it will see again another 2, so now it will be incremented and will become 2, and it will return the value of 2. And when we will verify in the second step, we will get, okay, 4 times 2 has occurred, and which is less than 6 by 2, 3, sorry, what I am saying, man. So it is greater than 3. It is greater than 3, right? So it is the majority element. Why it is happening? Because if you see, if such element exists which has more than n by 2 number of occurrences, then count variable will definitely point to that element only, because nobody can nullify that value. If it is there more than n by 2, how can some other element count will become more than that? Why not that element? Okay, so try to solve it by taking some more cases by yourself, and you will see why it is working properly. Okay, so now we will look into the time complexity. Wait a minute. Yeah, so what we are doing, we are traversing through the entire array. We are traversing through the entire array once. How much time? Order of n complexity only. We are not doing anything. We are just calculating the value of count in each step, and we are modifying the m index value, and we are just traversing the entire array. That's it. So that is why it is going to take order of n complexity. And in the step 2, what we are doing? In the step 2, we are verifying. For the verification also, we are going to traverse the entire array, which is going to take order of n. So order of n plus order of n, it is order of n only. Alright. So I hope you understood the concept. If not, then please go through the video once again. I know it is very tricky. This algorithm is tough to understand, but once you understand the concept, it is very simple and straightforward to write the code. Or else you can watch this video till the end, and once the code part is over, you can take few more examples and try to match it with the code, trace it with the code, and you can find out the way how this algorithm is working. Alright, now we'll look into the code now. If you have further doubt, you can post it in comment. So now we have created the class and main method is ready. We are having an array. Suppose these are the initial element, where we can see that 3 is the majority. We'll write the code and we'll check whether the output is 3 or not. Okay, so initially we are having two variable, count, which is initialized to 1. Now we are having m index, that is index of the majority element. So it is initialized to 0 initially. Now we will be having a for loop which starts from 1 and which goes till the end of the array. Now in each iteration we are checking whether the whether the array of ith element is equals to the m index value or not. If it is so, then we are incrementing the count value, or else we were decrementing the count value, right? Now once we decrement the count value, one more thing we were doing, we were checking whether the count value is equals to 0 or not. If it is 0, then we were modifying two things. We were shifting the m index value to the current location, that is ith location, and making the count value again 1. Even in my explanation, I did a lot of mistake while modifying this count value to 1. So please note here and do it carefully. Now after this is finished, so we will come to the second step, that is step 2, verification, right? We'll do now verification. It is very simple. We'll reinitialize the count value to 0. Now we'll count how many number of m index element are there. So for that we just need to write a loop which will go to 0 till the end. Okay, and each iteration we are checking if this error of ith element is equals to error of m index or not. Okay, so if it is so, we are incrementing the count value. Now at the end we will check. Now we will check what? We will check if this count value is greater than the n by 2 or not, that is array of length by 2 or not. If it is greater, then we will return or we will print here that value, what? Error of m index value. That is the correct answer. Else we will print no element found. No element found. Okay, now let us quickly execute it and check it how. Yeah, we are getting the answer as 3. Now let me explain the code once again. So we were having this array given to us. We initially count value is 1 and m index is pointing to the first location. So we are starting our for loop from the second index onward, and we are checking whether this element is equals to the m index element or not. If it is equal, then we are incrementing. If it is not equal, different value, then we are decrementing. And once we decrement, we are checking whether our count value is 0 or not. If it is 0, then we are shifting that m index value to the ith location and count value is becoming 1 again. So in this process it will go till the end of the array and it will be having some m index value. Now we don't know whether it is the majority element or not. If the array has a majority element, then definitely we are going to get the index of the majority element. If not, then for that purpose we should have a verification process. In that verification we will be traversing to the entire array and we will be checking whether m index value is equals to AR of I, and we will be counting the number of occurrences of the m index location element. If it is greater than array of length by 2, that is n by 2, then obviously it is going to be the majority index and that is going to be our answer. If not, then we will print no element found. This is it. It is very simple. Now let us change this array and let us keep all the value distinct and check whether it is giving us correct output or not. So yeah, 4, and let us delete. So 3, 2, 4, 1. So it should print no element found. Let us check whether it is working. Yeah, we got the answer as no element found. If you are watching this video till now, please hit the like button, and whatever doubt you are having, please post it in comment and subscribe the channel, and please share it with your friends. Thank you.